All right, so this is about the Truss build packet. I want you're supposed to read over it on how we're going to be building these, so you can come in ready to build, and we don't waste class time on that. So we're going to have some balsa wood. You're going to build them on these back pages here. You'll actually build the truss on here. You'll measure it first, and then cut your pieces and tape them on here and glue them together and stuff like that. And you'll tear off the other page when we're in the class and do truss 1 on here too. So that's kind of the beginning part. It goes into, how you should actually make this stuff measure up, make good joints with them. And then after we get it glued up, you will glue these gussets on the corners. And you'll see there's another page near the back with just gussets that you'll cut out and glue on. They actually do bond to the wood and kind of make it so it will not break at a joint. But the point of this video is to help you out with your work for Thursday and Friday. If you're in cohort A, it'll be your work on Tuesday and Wednesday if you're in cohort B, or whatever days we have. You'll see, so on Thursday here for cohort A, you're going to do your truss calculations for truss 1, and on Friday you're going to do it for truss 2. So this is good review for your quiz that's coming up. The days are just shifted over. So if you flip back to near the back but before the gusset page, you'll see on one side it's truss 1 calculation sheet. You're going to turn this in with your submission. And I basically redrew what you built, or what you're going to build with balsa wood. We're going to attach our weight here and break the bridge eventually, but on this page you're going to be doing the calculations that will determine, you should be able to figure out where your bridge is going to break first. So just like all our other truss calculations, you're going to start off by putting on your reaction forces in the Y direction, in the X direction if it's pins. So kind of do that. So you'll start with that, drawing your pictures on, and then you'll do your check if it's statically determinate, which is checking does 2 times the number of joints equal members plus reaction forces. So you're checking that stuff. Then 2, you're going to do the wrench thing, and this should be pretty easy on the wrench front. When you check, do your moments clockwise equal your moments counterclockwise, and show your work just like I always label mine. I always pick this as my pivot point, and then if you look at this, it's a really simple twisting force, because all I have is, RCY twisting counterclockwise versus, it's kind of hard to see this wrench, but versus this one, which is the 100-pound force twisting clockwise. So you're going to make your 2 wrenches, and you're going to check and make sure the clockwise force equals the counterclockwise force, and you'll solve for RCY. And then, still in number 2, you're going to make sure your force up, all your forces that go up, which are these 2, equal your forces down. And last but not least, you're going to check that your forces right are going to equal your forces left. So you're going to go through, and these are the steps we do on every problem. This should seem a lot easier than the ones we've been doing in class, because this is a really easy truss. So hopefully this prepares you well for an easy problem. After you get all that done, then you draw your free body diagram, right? And this is where all your answers go. So you're going to redraw this truss in pencil. See how I switched to pencil? And I have A here, B here, C here. and you're going to put in all the numbers you found from your previous problem for your up forces, and then you still have your down force. And the difference with a free body diagram is you erase the middles, and then you figure out which way your arrows go for the forces that are actually acting on these beams, right? And hopefully you're getting pretty good at it. The only thing that's going to fight this up force is a down force here, equal and opposite force because of Newton's law, and I name this force on beam AB, or FAB. And then if this is pushing down and left, I have to have a right force to battle it, and then you got an equal and opposite force. And this is force on AC. Don't pronounce that one. And then we got this one, kind of the same deal. This up must be fought by this down, equal and opposite, FBC. Right? So not a lot to solve for here. You do have one more step. That might be step 4. It is. Because you know what? I missed step 3. And step 3 is to find the angles. And you find the angles based off of thinking of these as big triangles. And you want to make sure you use inverse tangent, right? The angle equals inverse tangent of y over x. So when you're finding these angles, make sure you do, you already given these angles. But the way they got 29 degrees is the y was 2.75 and the x was 4.875 because the height of this triangle is 2.75. The base is that. So angle A would be inverse tangent of 2.75 over 4.875. So basically that's how they got the 29 degrees. You can just use the 29 degrees so we're all kind of on the same page. And then after you get your picture drawn and your numbers in here, you go after one joint at a time. So for step 5, you're going to attack each joint at a time. So, you want to always pick the joints that have the most information and the least amount of unknowns. This has too many unknowns. Yeah. So you go after A or C and just label your work as you go. Like joint A, and you'll redraw joint A with all the numbers on it. You got this force, you got this force with FAB, and you got this force with FAC. And then you'll know the number here. So you can attack these problems one at a time, show your work, show whether you're doing the ups and downs or the rights and lefts and all the work that goes with it. Okay, pretty similar. And then Truss 2, you're going to follow that exact same process. It's just a little more complicated. These are 90 degrees if you ever wonder. It's just a little more complicated in that there's more beams you have to find. So not any different in your steps. You still do statically determinate. Then you do the twisting forces, right? You're going to pick this as your pivot point. You got a twisting force down, you'll have a twisting force up. And then you find your angles. Oops, you already did. And then what else? Then you draw your free body diagram where you just erase the middles. So you'll keep on keeping on. There's a little more work on number 2, but you have all your measurements you need there. And yeah, best of luck to you, and email me if you get stuck or have questions, and hopefully that helps get you started in the right direction. And then we'll come in, and the day after we take our quiz, we'll start building these bridges and actually testing them and seeing whose bridge can hold the most force before breaking. All right, talk to you later, people.